Are you one of the many who dreams of becoming a data scientist? Keep watching this video if you're passionate about data science, because we will tell you how does it really work under the hood. Emma is a data scientist. Let's see how a day in her life goes while she's working on a data science project. Well, it is very important to understand the business problem first. In her meeting with the clients, Emma asks relevant questions, understands and defines objectives for the problem that needs to be tackled. She is a curious soul who asks a lot of whys, one of the many traits of a good data scientist. Now, she gears up for data acquisition to gather and scrape data from multiple sources like web servers, logs, databases, APIs, and online repositories. Oh, it seems like finding the right data takes both time and effort. After the data is gathered comes data preparation. This step involves data cleaning and data transformation. Data cleaning is the most time-consuming process as it involves handling many complex scenarios. Here, Emma deals with inconsistent data types, misspelled attributes, missing values, duplicate values, and whatnot. Then, in data transformation, she modifies the data based on defined mapping rules. In her project, ETL tools like Talent and Informatica are used to perform complex transformations that helps the team to understand the data structure better. Then understanding what you actually can do with your data is very crucial. For that, Emma does exploratory data analysis. With the help of EDA, she defines and refines the selection of feature variables that will be used in the model development. But what if Emma skips this step? She might end up choosing the wrong variables, which will produce an inaccurate model. Thus, exploratory data analysis becomes the most important step. Now, she proceeds to the core activity of a data science project, which is data modeling. She repetitively applies diverse machine learning techniques like KNN, decision tree, naive Bayes to the data to identify the model that best fits the business requirement. She trains the models on the training dataset and tests them to select the best performing model. Emma prefers Python for modeling the data. However, it can also be done using R and SAS. Well, the trickiest part is not yet over: visualization and communication. Emma meets the clients again to communicate the business findings in a simple and effective manner to convince the stakeholders. She uses tools like Tableau, Power BI, and ClickView that can help her in creating powerful reports and dashboards. And then finally, she deploys and maintains the model. She tests the selected model in a pre-production environment before deploying it in the production environment, which is the best practice, right? After successfully deploying it, she uses reports and dashboards to get real-time analytics. Further, she also monitors and maintains the project's performance. Well, that's how Emma completes the data science project. We have seen the daily routine of a data scientist is a whole lot of fun, has a lot of interesting aspects, and comes with its own share of challenges. Now, let's see how data science is changing the world. Data science techniques along with genomic data provides a deeper understanding of genetic issues in reaction to particular drugs and diseases. Logistic companies like DHL, FedEx have discovered the best routes to ship, the best suited time to deliver, the best mode of transport to choose, thus leading to cost efficiency. With data science, it is possible to not only predict employee attrition, but to also understand the key variables that influence employee turnover. Also, the airline companies can now easily predict flight delay and notify the passengers beforehand to enhance their travel experience. Well, if you're wondering, there are various roles offered to a data scientist, like data analyst, machine learning engineer, deep learning engineer, data engineer, and of course, data scientist. The median base salaries of a data scientist can range from $95,000 to $165,000. So that was about the data science. Are you ready to be a data scientist? If yes, then start today. The world of data needs you.
Hello and welcome to this session on data science with Python. So what are we going to do in this session? We will talk about what is data science and some of the basics of Python. As you may be aware, data science, we use either Python or R as some of the tools and programming languages. So this session, the focus is on Python. So we will talk about the basics of Python, why to learn Python, how to install Python, and then we will talk about some of the important libraries which are required for data analysis. And then we will go into a little bit of details about exploratory data analysis, and we will take an example there of loan prediction, and we will see a little bit about data wrangling using Pandas, which is one of the libraries of Python, and then we will end up with small predictive model or logistic regression model, which is a part of machine learning. And in case you need more details about machine learning, in this session we will probably not go into the details of machine learning. There is a separate session you might want to look at. There is a separate video on machine learning. You might want to take a look at that if you need more details. Here we are just giving a quick overview to see how we can use the scikit-learn library. So we will not go into a lot of details about the basics of machine learning. All right, so with that, let's move forward. So what is data science? Data science is about finding insights from the data. So if there is a lot of data, if you have sufficient data, how to analyze and find some insights out of it. This is what is data science all about. A couple of examples here. Customer prediction. Now, let's say you have a customer base and you want to find out who are most likely to buy your product. So you can use from your past behavior, you can probably develop a model and try to predict who are the people out of the 1,000 leads or potential customers who will actually buy. So there may be some patterns that you can use to predict. Similarly, service planning. So for example, you're running a restaurant and you want to know how many people will be coming or how many customers will be visiting your restaurant on a given day. Now, based on your historical data, you can build a model to predict that as well, so that there is no wastage of food and so on and so forth. So these are very quick and easy examples of how data science can be used in business. Now let's talk about Python. For doing data science, we need some kind of a programming language or a tool and so on. So this session will be about Python. There are other tools like, for example, R, and we will probably do a separate video on that. But this session is on Python, and you must have already heard Python is really becoming very popular. Everybody is talking about Python, not only data science, in IoT and AI and many other places. So it's it's getting very popular. So if you are not yet familiar with Python, this may be a good time to get started with it. So why do we want to use Python? So basically, Python is used as a programming language because it is for data science, because it has some rich tools from a mathematics and from a statistical perspective. It has some rich tools. So that is one of the reasons why we use Python. And if you see some of the trends, if you're probably tracking some of the trends, you will see that over the last few years, Python has become programming language of choice, and especially for data science, SAS was earlier one of the most popular tools, but now increasingly Python is being used for doing data science, and of course as well as R. One of the reasons, of course, is that Python and R are open source compared to SAS, which is a commercial product. So that could definitely be one explanation, but beyond that, I think it is the ease of understanding this language, the ease of using this language, which is also making it very popular, in addition to the availability of fantastic libraries for performing data science. What are the other factors? There are speed, then there are availability of number of packages, and then of course the design goal. Alright, so what are each of these? Design goal. Primarily, the syntax rules in Python are relatively intuitive and easy to understand. Thereby, it helps in building applications with concise and readable code base. So with a few lines of code, you can really achieve a lot of stuff. And then there are a lot of packages that are available that have been developed by other people, which can be reused. So we don't have to reinvent the wheel. And last but not least, the speed. So Python is a relatively faster language. Of course, it is not as fast as, let's say, C or C++, but then relatively it is still faster. So these are the three factors which make Python the programming language of choice. So if you want to get started with Python, the first thing obviously is to install Python. So there is some documentation, and there are some steps that you need to follow. So we will try to briefly touch upon that. Otherwise, of course, there is a lot of material available on how to install Python and so on. You can always look around, but this is one of the, again, there are different ways in which you can also install Python. So we will use the Anaconda path. There is a packaging tool called Anaconda. So we will use that path, you can also directly install Python, but in our session we will use the Anaconda route. So the first thing you need to do is download Anaconda, and this is the path for that. And once you click on this, you will come to a page somewhat like this, and download, you can do the corresponding download based on whether you have a Windows or Ubuntu. There is also a download possible for, or package available for Ubuntu if you are doing something on Ubuntu. So based on which operating system, in fact this page will automatically detect which operating system you are having, and it will actually suggest. So for example, you see here, if you're running Mac OS, then it will automatically detect that you have Macs, and the corresponding installers will be displayed here. Similarly, if you're on some flavor of Linux like Ubuntu or any other, then you will get the corresponding download links here. And then beyond that, you can also select which version of Python you want to install. Of course, the latest version is in the 3.x range at the time of recording this. 3.6 is one of the latest versions, but some of you may want to do or start with the earlier version, which is Python 2.7, 2.x, and you can download that as well. If you don't have anything installed, then my suggestion is start with Python 3.6. Alright, so once you do that, you will be able to install Python and you will be able to run Jupyter Notebook. Okay, so now that you know how to install Python, and if you have installed Python, let's take a look at what are the various libraries that are available. So Python is a very easy language to learn, and there are some basic stuff that you can do. For example, adding or printing a hello world statement and so on without importing any specific libraries. But if you want to perform data analysis, you need to include or import some specific libraries. So we are going to talk about those as we move forward. So Pandas, for example, is used for structured data operations. So if you, let's say, are performing something on a CSV file, you import a CSV file, create a data frame, and then you can do a lot of stuffs like data munging and data preparation before you do any other stuff, like for example machine learning or so on. So that's Pandas. SciPy, as the name suggests, it provides more scientific capabilities. Like for example, it has linear algebra, it has Fourier transform, and so on and so forth. Then you have Numpy, which is a very powerful library for performing n-dimensional or creating n-dimensional arrays, and it also has some of the stuff that is there in SciPy, like for example linear algebra and Fourier transform and so on and so forth. Then you have Matplotlib, which is primarily for visualization purpose. It has again very powerful features for visualizing your data, for doing the initial what is known as exploratory data analysis, for doing univariate analysis, bivariate analysis. So this is extremely useful for visualizing the data. And then Scikit-learn is used for performing all the machine learning activities. If you want to do anything like linear regression, classification, or any of this stuff, then the Scikit-learn library will be extremely helpful. In addition to that, there are a few other libraries, for example, networks and iGraph. Then of course a very important one is TensorFlow. So if you are interested in doing some deep learning or AI related stuff, then it would be a good idea to learn about TensorFlow, and TensorFlow is one of the libraries. There is a separate video on TensorFlow, you can look for that, and this is one of the libraries created by Google, open source library. So once you're familiar with machine learning, data analysis, machine learning, then that may be the next step to go to deep learning and AI. So that's where TensorFlow will be used. Then you have Beautiful Soup, which is primarily used for web scraping, and then you take that data and then analyze and so on. Then OS library is a very common library. As the name suggests, it is for operating system. So if you want to do something on creating directories or folders and things like that, that's when you would use OS. Alright, so moving on, let's talk in a little bit more detail about each of these libraries. So SciPy, as the name suggests, is a scientific library, and it very specifically, it has some special functions for integration and for ordinary differential equations. So as you can see, these are mathematical operations or mathematical functions. So these are readily available in this library, and it it has linear algebra modules, and it is built on top of Numpy. So we will see what is there in Numpy. So this is again, as the name suggests, the num comes from numbers. So it is a mathematical library, and one of its key features is availability of an n-dimensional array object. It is a very powerful object, and we will see how to use this. And then of course you can create other let's say objects and so on. And it has tools for integrating with C, C++, and also Fortran code. And then it of course also has linear algebra and Fourier transformation and so on, all these scientific capabilities. Okay, what else? Pandas is another very powerful library, primarily for data manipulation. So if you're importing any files, you will want to create it like a table. So you will create what is known as data frames. These are very powerful data structures that are used in Python programming. So Pandas library provides this capability. And once you import the data into data frame, you can pretty much do whatever you're doing like in a regular database. So people who are coming from a database background or SQL background would really like this, because it is they will feel very much at home, because it feels like you're viewing a table or using a table, and you can do a lot of stuff using the Pandas library. Now there are two important terms or components in Pandas, series and the data frame. I was just talking about the data frame. So let's take a look at what are series and what is a data frame. So within Pandas we have series and data frame. So series is primarily, some of you may also be knowing this as let's say an array. So it's a one-dimensional structure, data structure if you will. So in some other languages we may call it as an array, or maybe some others probably an equivalent of a list. In R perhaps, I'm not very sure on that aspect, but yes. So this is like a one-dimensional storage of information. So that is what is series. Whereas data frame is like a table. So you have a two-dimensional structure, you have rows and you have columns, and this is very, people, as I said, who are familiar with SQL and databases will be able to relate to this very quickly. So you have like a table, you have rows and columns, and then you can manipulate the data. So if you want to create a series, this is how you would create a code snippet. And as you can see, the programming in Python is very simple. There are no major overheads. You just need to import some libraries which are essential, and then start creating objects. So you don't have to do additional declaration of variables and things like that. So that is, I think, one key difference between Python and other programming languages. And what does this series contain? It has to contain these numbers 6, 3, 4, 6, and X is my object consisting of the series. So if you just say X, it will display the contents of X, and you will see here that it creates a default index. Then you have data frame. So if you want to create a data frame, as you can see, the series is like a one-dimensional structure. There is just like a row, one row of items, whereas a data frame looks somewhat like this. It is a two-dimensional structure. So you have columns in one dimension, and then you have rows in the other dimension. How do you create a data frame? You need to rather import Pandas, and then you import. In this case, we are basically creating our own data. So that's the reason we are importing Numpy, which is one of the libraries we just referred to a little bit before. So we are using one of the functionalities within Numpy to create some random numbers. Otherwise, this is not really mandatory. You probably will be importing the data from outside, maybe some CSV file, and import into the data frame. So that's what we are doing here. So in this case, we are creating our own test data. That's the reason we are importing Numpy as NP. And then I create a data frame saying pd.dataframe. So this is the keyword here. Similarly here in this case, while creating series, we said pd.series, and then you pass the values. Similarly here, you're saying pd.dataframe. Now in order to create the data frame, it needs the values in each of these cells. What are the values in the rows and what are the values in the columns? So that in our example we are providing using this random number generator. So np.random is like a class or a method that is available in Numpy, and then you are saying, okay, generate some random numbers in the form of a 4x3 matrix or 4x3 data frame. The 4 here indicates the number of rows, and the 3 here indicates the number of columns. So these are the columns, 0, 1, 2 are the columns, and these are the rows. Here 0, this is 1, this is 2, this is 3. Okay, and once again it will, when you display df, it will give us a default index. There are ways to omit that, but at this point we will just keep it simple. So it will display the default index and then the actual values in each of these rows and columns. So this is the way you create a data frame. So now that we have learned some of the basics of Pandas, let's take a quick look at how we use this in real life. So let's assume we have a situation where we have some customer data and we want to kind of predict whether a customer's loan will be approved or not. So we have some historical data about the loans and about the customers, and using that we will try to come up with a way to maybe predict whether loan will be approved or not. So let's see how we can do that. So this is a part of exploratory analysis. So we will first start with exploratory analysis. We will try to see how the data is looking. So what kind of data? So we will, of course, I'll take you into the Jupyter notebook and give you a quick live demo. But before that, let's quickly walk through some of the pieces of this program in slides, and then I will take you actually into the actual code and do a demo of that. So the Python program structure looks somewhat like this. The first step is to import all the required libraries. Now, of course, it is not necessary that you have to import all your libraries right at the top of the code, but it is a good practice. So if you know you are going to need a certain set of libraries, it may be a good idea to put, from a readability perspective, it's a good practice to put all the libraries that you're importing at the beginning of your code. However, it is not mandatory. So in the middle of the code somewhere, if you feel that you need a particular library, you can import that library and then start using it in the middle of the code. So that's also perfectly fine. It will not give any errors or anything. However, as I said, it's not such a good practice. So we will import all the required libraries. In this case, we are importing Pandas, Numpy, and Matplotlib. And in addition, if we include this piece of code, %matplotlib inline, what will happen is all the graphs that we are going to create, the visualizations that we are going to create, will be displayed within the notebook. So if you want to have that kind of a provision, you need to have this line. So it's always a good idea when you're starting off. I think it's a good idea to just include this line so that your graphs are shown inline. Okay, so these are the four. We will start with these 4 lines of code. Then the next step is to import your data. So in our case, there is a training data for loans by the name loan p_train.csv, and we are reading this data. So in this case, you see here, unlike the previous example where we created a data frame with some data that we created ourselves, here we are actually creating a data frame using some external data, and the method is very, very straightforward. So you use the read_csv method, and it is a very intuitive function name, and you say pd.read_csv and give the path of the file, CSV file. That's about it, and then that is read into the data frame df. This can be any name. We are calling it df. You can call xyz, anything. There's a name, just the name of the object. So head is one of the methods within the data frame, and it will give us the first 5. So this is just to take a quick look. Now you have imported the data. You want to initially have a quick look how your data is looking. What are the values in some of the columns and so on and so forth, right? So typically you would do a head, df.head, to get the sample of, let's say, the first few lines of your data. So that's what has happened here. So it displays the first few lines, and then you can see what are the columns within that, and what are the values in each of these cells, and so on and so forth. You can also, typically you would like to see if there are any null values, or are there any, is the data for whatever reason is invalid or looking dirty for whatever reason, some unnecessary character. So this will give a quick view of that. So in this case, pretty much everything looks okay. Then the next step is to understand the data a little bit overall for each of the columns. What is the information? So the describe function will basically give us a summary of the data. What else can we do? Pandas also allows us to visualize the data, and this is more like a part of what we call it as univariate analysis. That means each and every column you can take and do some plots and visualization to understand data in each of the columns. So for example, here the loan amount column we can take, and then the hist basically hist method will create a histogram. So you take all the values from one column, which is loan amount, and you create a histogram to see how the data is distributed, right? So that's what is happening here. And as you can see, there are some extreme values. So this is again to identify, do we have to do some data preparation? Because if the data is in a completely haphazard way, the analysis may be difficult. So these are the initial or exploratory data analysis is primarily done to understand that and see if we need to do some data preparation before we get into the other steps like machine learning and statistical modeling and so on. So in this case, we will see that here by plotting this histogram, we see that there are some extreme values. So there are some values, a lot of it is around 100 range, but there is also something, one or two observations in the 700 range. So it's pretty scattered in that sense, or they're not really scattered, distributedly scattered, but it is randomly scattered. So the range is really huge. So what can we do about this? So there are some steps that we need to do, normalization and so on. So we'll see that in a bit. So this is for one of the columns. Let's take another column, which is applicant income. Similar situation. You have most of your observations in this range, but there are also some which are far off from where most of the observations are. So this is also this also has some extreme values. So we'll have to see what can be done. Credit history is the binary value. So some people have a 0 value and some will have credit history of 1. This is just like a flag. So this basically is telling us how many people have a 1 and how many people have 0. So looks like majority of them have a value of 1 and a few, about 100 of them, have a value of 0. Okay, what else can we do? So we now understood a little bit about the data. So we need to do some data wrangling or data munging and see if we can bring in some kind of normalization of all this data. And we will kind of try to understand what is data wrangling and before we actually go into it. Okay, so data wrangling is nothing but a process of cleaning the data. If let's say there are multiple things that can happen. In this particular example, there were no missing values, but typically when you get some data, very often it will so happen that a lot of values are missing. Either they are null values or there are a lot of zeros. Now you cannot use such data as it is to perform some, let's say, predictive analysis or perform some machine learning activities and so on. So that is one part of it. So you need to clean the data. The other is unifying the data. Now if these ranges of this data are very huge, some of them are going from, some columns are going from 0 to 100,000 and some columns are just between 10 to 20 and so on. These will affect the accuracy of the analysis. So we need to do some kind of unifying the data and so on. So that is what data wrangling is all about. So before we actually perform any analysis, we need to bring the data to some kind of a shape so that we can perform additional analysis, actual analysis on this and get some insights. Now, how do we deal with missing values? This is a very common issue when we take data or when we get data from the business, when a data scientist gets the data from the business. So we should never assume that all our data will be clean and all the values filled up and so on, because in real life, very often the data will be dirty. So data wrangling is the process where you kind of clean up the data. First of all, identify whether the data is dirty and then clean up. So how do we find some data is missing? So there are a few ways. You can write a small piece of code which will identify if for a given column or for a given row, any of the observations are null primarily. So this line of code, for example, is doing that. It is trying to identify how many null values or missing values are there for each of the columns. So this is a lambda function, and what we are saying is find out if a value is null and then you add all of them. How many observations are there where this particular column is null. So it does that for all the columns. So here you will see that for loan ID, obviously it's an ID, so there are no null values or missing values. Gender has about 13 observations where the values are missing. Similarly, marital status has 3 and so on and so forth. So we'll see here, for example, loan amount has 21 observations where the values are missing. Loan amount term has 14 observations and so on. So we'll see how to handle this missing values. So there are multiple ways in which you can handle missing values. If the number of observations are very small compared
compared to the total number of observations, then sometimes one of the easy ways is to completely remove that data, or delete that record, exclude that record. So that is one way of doing it. So if there are, let's say, 1,000,000 records and maybe 10 records are having missing values, it may not be worth doing something to fill up those values. It may be better off to get rid of those observations, right? So that is, the missing values are proportionately very small. But if there are a relatively large number of missing values, if you exclude those observations, then your accuracy may not be that very good. So the other way of doing it is, we can take a mean value for a particular column and fill up wherever there are missing values, fill up those observations or cells with the mean value. So that way what happens is, you don't give some value which is too high or too low, and it somehow fits within the range of the observations that we are seeing. So this is one technique. Again, it can be case to case, and you may have to take a call based on your specific situation, but these are some of the common methods. If you see in the previous case, loan amount had 21, and now we went ahead and filled all of those with the mean value. So now there are 0 with missing values. Okay, so this is one part of a data wrangling activity. What else you can do? You can also check what are the types of the data. So df.dtypes will give us what are the various data types. So alright. So you can also perform some basic mathematical observations. We have already seen that mean we found out. So similarly, if you do call the mean method for the data frame object, it will actually perform or display or calculate the mean for pretty much all the numerical columns that are available in this, right? So for example, here applicant income, co-applicant income, and all these are numerical values. So it will display the mean values of all of those. Now, another thing that you can do is, you can actually also combine data frames. So let's say you import data from one CSV file into one data frame and another CSV file into another data frame, and then you want to merge these because you want to do an analysis on the entire data. Okay, one example could be that you have data in the form of CSV files, one CSV file for each month of the year, January, February, March, each of these are in a different. So you can import them into, let's say, 12 data frames, and then you can merge them together as a single data frame, and then you perform your analysis on the entire data frame or the entire data for the year. So that is one example. So how do we do that? This is how we do. Again, in this case, we are not importing any data. We are just creating some random values, using some random values. So let's assume I have a data frame which is by the name 1, and I assign some random values here, which is a 5x4 format. So there are 5 rows and 4 columns, and this is how my data frame 1 looks. And then I create another data frame, which is data frame 2, again random numbers of the format 5x4, and I have something like this. Now I want to combine these two. How do I combine these two? I can use the concatenate or concat method, and I can combine these two. So pd.concat, and it takes the data frames 1 and 2. If you have more of them, you can provide them, and it will just simply add all of them, merge all of them, or concatenate, whatever you call, whichever term you call, it will. So of course we have to make sure that the structure remains the same. Like I said, this could be, let's say, sales data coming for 12 different months, but each of the files has the same structure. So now you can combine all of them, merge all of them using the concat method. If we have, let's say, structure is not identical, then what will happen? Let's say we have these two data frames. One has a column by the name key, and the second column is lval, and a second data frame which has a column by the name key, but the second column by the name rval, not lval. So you see here the structure is not identical. So you can still combine them, but then the way they get combined or merged is somewhat like this. So it takes the key as a common parameter between them. Some common column has to be there, otherwise this will not work. And then we have to use merge instead of concatenate. And when we do a merge, then we get the result will be in this format. What it does is it uses the key as a common thread between them, and then it kind of populates the values accordingly. So if you see here, the first one had foo and bar for key, and then it had L values of 1 and 2, right? So if we go back, foo and bar had 1 and 2 L values. So that's what we see here, 1 and 2. Whereas in the right data frame, we had foo, bar and bar as a second time, and then our values are 3, 4 and 5. So what it has done for foo, it has put for the existing, right? For foo is already existing because it has come from left. So it will just put the value of r val here, which is 3. Similarly, it will put 4 here because for bar, if you go back, for bar the value is 4. And since it has one more value of bar, it will go and add this 5 as well. The only thing here is that this one had, for example, left had only 2 values and only 1 value for bar. But since we are appending or merging, and there are 2 key values with the bar, therefore it will kind of repeat the value of lval here. So that's what we are seeing in this case, right? So L value appears twice, the number 2 appears twice, but that is because R value, there are 2 of them. Okay. All right. So that is how, when you don't have identical structure, that's how you merge. Now we will talk a little bit about Scikit-learn. So Scikit-learn is a library which is used for doing machine learning or for performing machine learning activities. So if you want to do linear regression, logistic regression and so on, there are easily usable APIs that you can call. And that's the advantage of Scikit-learn. And it provides a bunch of algorithms. So I think that is the good part about this library. So if you want to use Scikit-learn, obviously you need to import these modules, and also there are some sub-modules you may have to import based on what you're trying to use. Like for example, we know if we want to use logistic regression. Again, people who are probably not very familiar with machine learning, there is a separate module for machine learning. You may want to take a look at that, but we will just touch upon the basics here. So machine learning has some algorithms like linear regression, logistic regression, and random forest classification and so on. So that is what we are talking about here. So those algorithms are available, and if you want to use some of them, you need to import them and from the Scikit-learn library. So Scikit-learn is the top level library, which is basically sklearn, right? And then it has a kind of subparts in it. You need to import those based on what exactly you will be or which algorithm you will be using. So let's take an example as we move, and we will see that whenever we perform some machine learning activity, those of you who are familiar with machine learning will already know this. We split our labeled data into 2 parts, training and test. Now, there are multiple ways of splitting this data. How do we, some people do it like 50-50, some people do it 80-20, which is training is 80 and test is 20, and so on. So it is an individual preference. There are no hard and fast rules. By and large, we have seen that training data set is larger than the test data set. And again, we will probably not go into the details of why do we do this at this point, but that's one of the steps in machine learning. So Scikit-learn offers a readily available method to do this, which is train test split. All right. So in this example, let's say we are taking the values x and y are our values. X is the independent variables and y is our dependent variable. Okay. And we are using these two. And then I want to split this into train and test data. So what do? We import the train test split submodule from within Scikit-learn, which is sklearn, right? So within that we import train test split, and then you call this train test split method or function or whatever you call it and pass the data. So x is all the values of the independent variables and y is our labels. So you pass x and y, and then you specify what should be your size of the test data. So only one you need to specify. So if you say test size is 0.25, it is understood that train size will be 0.75. So you're telling what should be the ratio of the split. So technically nothing prevents you from giving whatever you like here. So you can give test as 80 and train as 20, so whichever way, but then the normal practice is you will have the training data set would be larger than the test data set, and typically it would be 80-20, 75-25 or 65-35, something like that, right? So that is the second parameter, and this is just to say that the data has to be randomly split. So it shouldn't be like you take the first 75% and put it in training and then the next 25% and put it in test, so such a thing shouldn't happen. So we first set the state, random state, so that the splitting is done in a very random way. So they are randomly picked up the data and then put it into training and test, and then this results in these 4 data frames. So xtrain and xtest and ytrain and ytest. Okay, so that is basically the result it will return. Now that the splitting is done, let's see how to implement or execute logistic regression. So in logistic regression, what we try to do is try to develop a model which will classify the data. Logistic regression is an algorithm for supervised learning for performing classification. So logistic regression is for classification, and usually it is binary classification. So binary classification means there are two classes. So either like a yes, no, or for example, customer will buy or will not buy. So that is a binary classification. So that's where we use logistic regression. So let's take a look at the code, how to implement something like that using scikit-learn. So the first thing is to import this logistic regression submodule or subclass, whatever you call it, and then create an instance of that. So our object is classifier. So we are creating an object by the name. This is a name, by the way. You can give any name. In our case, we are saying classifier. We say classifier is equal to logistic regression. So we are creating an instance of the logistic regression variable or class or whatever. Okay. And you can pass a variable or a parameter rather, which is the random state is equal to 0. And once you create the object, which in our case is named classifier, you can then train the object by calling the method fit. So this is important to note. We don't call there is no method like train here, but we call what is known as, there is a method called fit. So you're basically, by calling the fit method, you're training this model. And in order to train the model, you need to pass the training data set. So x_train is your independent variables, the set of independent variables, and y_train is your dependent variable or the label. So you pass both of these and call the fit function or fit method, which will actually result in the training of this model classifier. Now, this is basically showing what are the possible parameters that can be passed or initiated when we are calling the logistic or the instance of logistic regression. So this is, but you can also look up the help file if you have installed Python. So some of these are very intuitive, but some you may want to take a look at the details of what exactly they do. All right, so moving on. Once we train the model by calling fit, then the next step is to test our model. So this is where we will use the test data. You need to pay attention here. Here I am calling, so there are two things. One is, in order to test our data, we have to actually call what is known as the method known as predict. Right? So here, this is where, so the training is done. Now is the time for inference, isn't it? So we have the model. Now we want to check whether our model is working correctly or not. So what do? You have your test data. Remember, we split it, 25% of our data was stored here, right? We split it into test and training. So that 25% of the data we pass to and call the method predict, so that the model will now predict the values for y. Right, so that's why here we are calling it as y_predict. And if we display here, as I said, this is a logistic regression, which is basically binary classification. So it gives us the results like yes or no in this particular case. And then you can, so this is what the model has predicted or model has classified. Now, but we also know we already have the labels for this. So we need to compare with the existing labels, with the known labels, whether this classification is correct or not. So that is where is the next step, which is basically calculating the accuracy and so on will come into play. Okay, so in this case, the first thing, most important thing to note is we do the prediction using predict, and here we are passing x_test and not train, right? In this case, we did x and y train. So again, one more point to be noted here. In case of training, we will pass both the independent variables and also the dependent variables, because the system has to internally, it has to verify. That is what is the training process. So what it will do, it will take the x values, it will try to come up with the y value and compare with the actual y value, right? So that is what is the training method. So that's why we have to pass both x as well as y. Whereas in case of predict, we don't pass both. We only pass because we are pretending as if this is the actual data. So in actual data, you will not have the labels, isn't it? So we are just passing the independent variables, and the system will then come up with the y values, which we will then, okay, remember, we also know the actual value. So we will compare this with the actual values and we will find out whether how accurate the model is. So how do we do that? We use what is known as a confusion matrix. So this is also readily available available in the Python library. So we import this confusion matrix, and some of you who already know machine learning will find this familiar, but those who are new to machine learning, this confusion matrix is nothing but this matrix, this kind of a matrix, which basically tells how many of them are correctly predicted and how many of them are incorrectly predicted. So some of the characteristics, let's quickly spend some time on this confusion matrix itself. The total numbers out here, these are just the numbers. These are like number of observations. Then the accuracy is considered to be highest when the numbers or the sum of the numbers across the diagonals is maximum, okay, and the numbers outside of the diagonals should be minimum. So which means that if this model was 100% accurate, then the sum of these two, there would have been only numbers in these two along the diagonal. This would have been 0 and this would have been 0. Okay, so that is like 100% accurate model. That is very rare, but just that you are aware. So just to give an idea. Okay, all right. So once you have the confusion matrix, you then try to calculate the accuracy, which is in a percentage. So there are two things that we can do from a confusion matrix, or that we can calculate from a confusion matrix. One is the accuracy and the other is the precision. What is the accuracy? Accuracy is basically a measure of how many of the observations have been correctly predicted. Okay, so let's say this is a little bit more detailed view of the confusion matrix. It looks very similar like as we saw in this case, right? So this is a 2 by 2 matrix. That's what we are seeing here, 18, 27, 2, 103. So 18, 27, 2, 103. Now, but what are these values? That is what is kind of the labels are shown here in this. So there are altogether 150 observations. So as I said, the sum of all these four, right? 18 plus 27 plus 103 plus 2 is equal to 150. That's the first thing we have to observe. The sum of all these values will be equal to the sum of test observations, number of test observations. We have 150 test observations, because remember we had about 500. We split that into 2575. So that is why we have 150 here and I think 350 in the training data set. Okay, so that we get the numbers correct. So that's the first thing. Now the next thing is, let's take a look at the actual values. This view is the actual view. So there are actually, right, in the actual data we have labels yes and no. So as per the actual data, there are 45 observations tagged as no, and similarly there are 105 observations that are tagged as yes or labeled as yes. Okay, now I know for the first time when you're seeing this it may be a little confusing, but just stay with me. Okay, so this is the actual part of it, and this side tells us the predicted part of it. So our model has predicted, and it has totally predicted 20 of them as no, right? So that is what this is. Totally 20 of them it has predicted as no, and it has predicted 130 of them as yes. Okay, I hope this part is clear. So before we go into the middle part, let us first understand what exactly are these numbers. So actually tagged as no, there are 45 total. Actually tagged as yes, there are 105. And predicted no, there are 20. Predicted as yes, there are 130. This is the result from our model. Okay, this is the result from our model, and this is the actual value which we already know because this is our label data. That's the first thing. Now let us take a look at each of these individually. Okay, now what are the options we have? Once again, okay, so now what is happening here? Let us look at these values. So this 18 says that these are actually tagged as no, and the model has also predicted as no, which means this is what is known as a true positive, right? Or true negative, sorry, right? Which means that our model has predicted it correctly. It is negative because it says no. So, and it has also predicted no, so it is known as what is known as true negative. Okay, now let's come to this side of it. That way we are talking about the diagonal. Remember I said most of the values should be in the diagonal. Okay, so that means these 18 are correctly tagged. They are labeled as no, and our model has predicted as no. So these are correctly tagged, and these are known as true negative. Okay, similarly, if we come diagonally down, there are 103 observations which are labeled as yes, actual value is yes, and our model has also predicted as yes, and these are known as true positive values. Positive because of this yes. Okay, right? So what is important is this is true, this is also true. So we have to make sure that the maximum number of values are in the true section. Okay, true positive and true negative. That's the reason I said the sum along the diagonal should be maximum. Now let's say if our model was 100% accurate, this sum, in this case it is only 103 plus 18, which is 121. But if our model was accurate, the sum of these two would have been 150. That means it's a perfect model. Okay. All right. Now what else? Since we covered these two, let's also cover these two. So here this says that 27 of them were actually labeled no, but our model has predicted as yes. That means this is wrong, right? Similarly, these are 2 of them where the actual value is yes, but our model has predicted as no. That means it's a wrong prediction. So you get the point? So therefore, along the diagonals are the correct values, whereas in other places it is all wrong values or wrong predictions. Okay. Now, how do we calculate accuracy from this information? So the way to calculate accuracy is, so we say, okay, there are total observations are 150. And what are the correctly predicted values? These are the correctly predicted values, which is 18 plus 103. So this will give us our accuracy. So 103 plus 18, which is 121, divided by our total observations, which is 150, is our accuracy, which is 0.8, or we can say it is 80%. Okay. Now, there is another concept called precision. So precision is given by the formula true positives divided by the predicted positives, totally predicted positives. Okay. What do we mean by that? Which are the true positives here? Remember, which are the true positives? We just recall, we just talked in the previous slide. Which are the true positives you see here? So this 103 are the true positives, which means that the value is positive, actual value is positive, predicted value is also positive. So that's why it's called a true positive. So 103 divided by, so that is our true positive, 103 divided by totally predicted as yes. Now what is totally predicted as yes? Remember, 130 of them have altogether been predicted as yes. Not that they are correctly predicted, only 103 have been correctly predicted, but 130 of them have been predicted as yes. So precision is basically the ratio of these two. Out of the totally predicted, how many of them are actually true? That ratio. So 103 by 130, which is again about 80%, is the precision. That's how you calculate precision. So this is just a simple formula and a term that you need to remember. So accuracy is, you need to take total of true positive and true negative divided by the total number of observations, whereas precision is true positives divided by the totally predicted positives. Okay. So that is our accuracy and precision. Now, what we did, the accuracy calculation was manual, but we can also use some libraries which are already existing and the functions within that library. So Scikit-learn provides one such method. So for example, accuracy underscore score is one such method. So if you use that and pass your test and predicted values, only the y you need to pass, right? The dependent variable values. So if you pass that, it will calculate it for you. So in this case, again, as you can see, it still calculates the same, which is 80%, which we have seen here as well. Okay. So this can be done using the method. Great. So that's pretty much what we have done here. Before we conclude, let me take you into the code and show you how it actually looks. Okay. So this is our code. Let me run it. Okay, one by one. We have already seen most of the steps in the slides, so I will run this in the actual Jupyter Notebook. Some of you, if you're not yet familiar with Jupyter Notebook, again, there are other videos we created on how to install Jupyter Notebook and how to set up Jupyter Notebook and so on. In this tutorial also, there was one slide on how to install Python and Jupyter Notebook. If you have not yet done, please do that, so that then you can actually walk through this code while you're watching this. Okay, so what are we doing here? We are importing the libraries, required libraries. Recall here we have Pandas, we have Numpy, and for visualization we have matplotlib, and this line is basically reading the CSV file. So we have the CSV file locally on our local drive, and this is where I'm checking the data. So I'm starting with my exploratory analysis, how the data is looking. So it looks good. There are no major missing values or anything like that. So it will display all the columns, and it will show me the first 5 rows when I'm using this head function. And then I want to see a kind of a summary of each of the numerical columns. So that's what I'm doing here. So these are the numerical columns, and it gives a summary like how many observations are there, what is the mean, standard deviation, minimum, maximum, and so on and so forth for each of them. And then you can do some visualization. So this is the visualization for this. Okay, the next step is to view the data visualization, and we will do that using a histogram for a couple of these columns. So in this case, I'm taking a look at the loan amount, and if I create the histogram, it displays the data here in the form of a histogram. One thing that we gather from this, as I mentioned in the slides as well, is how the data is kind of scattered. So while most of the values are in this range 0 to 300 range, there are a few extreme values around the 700 range. So that is one information we get from this histogram. Similarly, for the applicant income, if we draw a histogram, something similar we can see that while most of the values are in this range 0 to 20,000 range, there are a few in the range of 80,000 and probably 65,000 and so on. Okay, so the next step is to perform data wrangling, where we will check if any data is missing and how to fill those missing values and so on. So in this case, we will just check for all the columns, how many data or how many entries are there with missing values. So this is the result. So loan ID has all the columns or all the cells filled. Gender has 13 missing values. Marital status has 3 missing values, and so on and so forth. Loan amount has 21. And this is what we are going to show you how to remove these missing values. So when you have missing values, as I mentioned during the slide, there are a couple of ways of handling that. One is you can completely remove those, or you fill in with some meaningful values. So in this case, we will fill the missing values with the mean value of the loan amount. So let's go ahead and do that. And now if we check here, now loan amount, number of missing values is 0, because what we did was for all these 21 cells where the values were missing, we filled with the mean value of the loan amount. So now there are no more missing values for loan amount. We can do this for other columns as well, but this was just one example, so we have shown it here. Okay, so we will run this for credit history and loan amount term as well. And then if we calculate the mean of pretty much all the numerical columns, that's the method call. So df.mean will give us the mean of all the numerical values. And another thing that we can do is if you want to find out what are the data types of each of these columns, so you can call df.dtypes and get the data types. Of course, it may not be that very useful. Most of the cases this is an object, but for example, this one it shows as int 64 and there are float 64 and so on and so forth. Now, in addition to doing the exploratory data analysis, we can do some machine learning activity as well. So in this case, we are going to do logistic regression. So this is the example that I have shown you in the slides as well. This is the actual code for that. All right. So the first step here is to import the libraries. And then the next step is to separate the independent variables and the dependent variables. So X is our independent variable and Y is our dependent variable. So we separate the data into 2 parts, and this will be our target as well, right? So that's how we separate it. Now we have to split the data into training and test data sets. As I mentioned during the slides, we use the train test split method, and when we call this and pass the independent variables and the dependent variables, and we specify the test size to be 0.25, which means the training size will be 0.75, which is nothing but you split the data into training data set, which is 75%, and test data set which is 25%. Okay, so once you split that, you will have all your independent variables data in xtrain, the training data, which is 75% of it. Similarly, independent variables for test will be in x_test, and dependent variables train will be in y_train, and dependent variable test will be y underscore test. Once we do this, we have to do a small exercise for scaling. Remember, we had some data which was kind of very scattered. There were some extreme values and so on. So this will take care of that so that the data is normalized, so that before we pass to our algorithm, the data is normalized so that the performance will be much better. The next step is to create the instance of logistic regression object. So that's what we are doing here. So classifier is our logistic regression instance, right? Classifier is equal to logistic regression, we are saying. So one instance of logistic regression is created, and then we call the training method. The name of the method actually is fit, but what it is doing is it is taking the training data. X is the training data, the independent variables, and Y is the dependent variables. So we are taking both of these and the model gets trained. So the method for calling the training is fit. Okay, so it gives us the output, and then once we are done with the training, we do the testing. And once again, just to recall, in the slides when I was showing you the slides also I mentioned, we don't pass Y here while we are testing. While for training we do pass Y, but right, so for fit we are passing X and Y, but for test we are only passing X, something you need to observe, because Y will be calculated by the model, and we will then compare that with the known value of Y to measure the accuracy. So that's what we will do here, and the method that is called here is predict. So this will basically create or predict the values of Y. Now we have, in this case, a binary classification. So the outputs are yes or no. Y indicates yes and N indicates no. So Y or N is the output. Now how do we measure the accuracy? As we have seen earlier, I described how confusion matrix works and how we can use confusion matrix for calculating the accuracy. That's what we are seeing here. So this is the confusion matrix, and then you want to do the measure the accuracy, you can directly use this method, and we find that it is 80%. So we, in the slides we have seen, when we calculate manually as well, we get an accuracy of 80%. Okay, let's go back to our slides and do a summary. So what we have done in this session, we talked about what is data science and why Python is being used, why it is becoming so popular, how to install Python, and we talked about the various libraries in Python like Pandas, SciPy, Numpy, and so on. And then we took a couple of examples and wrote the code and demonstrated the code for performing exploratory analysis and performing data wrangling or data manipulation. And then we, at the end, we did one example of machine learning using scikit-learn library and performed the logistic regression example.
Welcome to Data Science Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Before we dive in and start going through the questions one at a time, we're going to start with some of the logical kind of concept that enters in a lot of interviews. In this one, you have two buckets, one of 3 liters and the other of 5 liters. You're expected to measure exactly 4 liters. How will you complete the task? And note, you only have the 2 buckets. You don't have a third bucket or anything like that, just the 2 buckets. And the object of the question like this is to see how well you are thinking outside the box. In this case, you're in a larger box. You have 2 buckets. And also the pattern which you go on. And what that means is if you look at the 2 buckets, and we'll show you their answer in just a second, you have a bucket with 3 liters and a bucket with 5 liters. And the first thought is, what happens if you go from left to right? So we have a direction. And what happens if you pour the 3 liters into the 5 liter bucket? Well, if you pour the 3 liters into the 5 liter bucket, you have an empty bucket of 3 liters. And what's really important here is, thinking outside the box, you realize that you have a 5 liter bucket that has 3 liters in it and 2 empty liters. So you have 2 additional liters you can fill up. If we continue that process, we can pour from the left to right, from the small bucket to the large bucket. You can now measure in 2 additional liters into the 5 liter bucket. And 3 minus 2 is 1. And you can keep doing that. You can empty the 5 liter bucket in, pour those 3 liters in, that 1 liter in, and then you can pour 3 liters in. What's cool about these questions as you explore them is you realize there's multiple ways usually to solve them. I went from small bucket to big bucket. The Simplilearn team, their solution that they pulled out was you fill the 5 liter bucket and empty it into the 3 liter bucket. Now you're left with 2 liters in the 5 liter bucket. So that's great. We can empty the 3 liter bucket. So now we're going from large to small. Remember, we went from small to large. So you can go both either way, but you have to go one way or the other, it turns out. And you can empty the 3 liter bucket and pour the contents of the 5 liter bucket in it. So the 3 liter bucket now has 2 liters. And if it has 2 liters, that means it has an empty 1 liter. And by now you probably have guessed that if you have that empty space, you can start using that empty space of 1 liter as a measuring. So we fill the 5 liter bucket again, and we pour the water in the 3 liter bucket. It already has the 2 liters, and so we're only pouring 1 liter in there, and 5 minus 1 is 4. So interview questions, they break up into all kinds of different patterns. We have logic like this one, which is a lot of fun. We have questions that come up that are more vocabulary. List the difference between supervised and unsupervised learning. Probably one of the fundamental breakdowns in data science. And supervised learning uses known and labeled data as input. Supervised learning has a feedback mechanism. Most commonly used supervised learning algorithms are decision tree, logistic regression, support vector machine. And you should know that those are probably the most common used right now, and there certainly are so many coming out. So that's a very evolving thing, and be aware of a lot of the different algorithms that are out there outside of the deep learning. Because a lot of these work faster on raw data and numbers than a deep neural network would. Unsupervised learning uses unlabeled data as input. Unsupervised learning has no feedback mechanism. Most commonly used unsupervised learning algorithms are k-means, clustering, hierarchical clustering, the Aporia algorithm. And there certainly are more. I'm going to say k-means definitely is at the top of the list, and the hierarchical clustering, those two are used so many times. So really important to understand what those are and how they're used. And most important is understand that supervised learning is you have your data set where you have training data and you have all those different pieces moving around, but you're able to train it. You know the answers. And unsupervised, we're just grouping things together that look like they go together. How is logistic regression done? Logistic regression measures the relationship between the dependent variable, our label, what we want to predict, and the one or more independent variables, our features, by estimating probability using its underlying logistic function, sigmoid. And whenever I draw these charts, I always end up drawing them the right-hand side first, because you want to know what your output is. What is you want out of here? And the left-hand side, what do you have going in? So you have your in and out. You can see we have a nice labeled image here to help you remember this. We have our inputs, we have our linear model, we have our probabilities. What are the probabilities of it being a certain way based on these features coming in? The sigmoid function, and it's important to note that the sigmoid function is maybe the most commonly used, but it's only one of a number of functions that are out there. And the sigmoid function turns our probabilities into a value between 0 and 1, or very close to 0 and very close to 1, between 0.1 and 0.009. And based on that, we generate an answer, in this case is 0 or 1. How is logistic regression done? So last time we talked about the sigmoid function. Generally, depending on what your interview and level of math and what expertise you're going in for the market, you'll have to understand that formula of the probability equals 1 over 1 plus e to the negative y. And that's e to the base 2. So you have your probability function or your sigmoid function, which pushes it. As you can see, we have a nice visual of that, and that helps a lot to have that visual on the sigmoid function. You definitely should know your y equals m times x plus c, your basic Euclidean geometry of forming a line, and the slope plus the intercept, the y-intercept. And then you have your natural log, and the natural log is to the e as opposed to a base 2 or base 10. So your natural log to the e of the probability over 1 minus a probability equals your m times x plus c, or your Euclidean line. That helps a lot as far as the graphing and understanding the sigmoid function. So we'll just keep pushing on to question number 3. Explain the steps in making a decision tree. And I noticed last time we brought up the decision tree in the forest, a lot of questions came up. What is the difference? So let's go through that. When you make a decision tree, you're going to take the entire data set as input. You're going to calculate entropy of the target variable as well as the predictor attributes. And remember, entropy is just how chaotic is it. So if you have banana and grapes and oranges, if you're mixing in fruit and that's your data coming in, you have all these different objects that are so separate from each other, and the more they become uniform, the lower the entropy. And we call that information gain. So we gain information on sorting different objects from each other. So you have your entropy, you have to calculate your information gain of all attributes, and then you choose the attribute with the highest information gain as the root node. So if you can separate your group and each group, chaos in each group is lowered, whichever split lowers the chaos the most, that's where you split it, and that's your root node. At that point, you repeat the same procedure on every branch till the decision node of each branch finalized. So understanding that setup is pretty important as far as decision trees. And you can see here we have a nice visual of a decision tree. For example, if you want to build a decision tree to decide whether we should accept or decline a job offer, since these are interview questions, that's a good one to ask. And just as a tip, you should be pretty aware aware of the formula for entropy and information gain. So you need to look those up if you don't remember those. And the salary, if it's greater than 50,000, no, decline the offer. Yes, it's got a good salary. The commute is greater than an hour. Yes, decline the offer. No. Offers incentives. Yes, accept the offer. No incentives, decline the offer. So we use decision tree pretty much for everything if you want. And if you have a decision tree, then you also should understand how do you build a random forest model. And remember that a random forest is built up of a number of decision trees. So if you split your data up into a lot of different packages and you do a decision tree on each of those different groups of data, the random forest is bringing all those trees together. So how do you build a random forest model? Randomly select k features from a total of m features, where k is less than m. Among the k features, calculate the node D using the best split point. Split the node into daughter nodes using the best split. Repeat steps 2 and 3 steps until leaf nodes are finalized. Build forest by repeating steps 1 to 4 for n number times to create n number of trees. So you can see it's got the same build pattern as the tree, but instead you're building a number of different trees, little small trees, so it all have an n leaf node. Random forest has a vote at the end, and whoever gets the most votes wins. That's the answer. How can you avoid overfitting of your model? Very important question in any kind of mathematical, scientific, data science setup, in any of them. There are 3 main methods to avoid overfitting, and you should really understand overfitting. Overfitting means that your model is only set for a very small amount of data and ignores the bigger picture. Keep the model simple. Take into account fewer variables, thereby removing some of the noise in the training data. Good advice for any programming at all. Use cross-validation techniques such as k-folds cross-validation. Use regularization techniques such as lasso that penalize certain model parameters if they're likely to cause overfitting. And you should also be well aware that your cross-validation techniques, that's like a pre-data, or your lasso and your regularization techniques are usually during the process. So when you're prepping your data, that's when you're going to do a cross-validation, such as like splitting your data into 3 groups, and you train it on 2 groups and test it on 1, and then switch which 2 groups you test it on, that kind of thing. So can you solve, another one of these, I love these things. There are 9 balls, out of which 1 ball is heavy in weight, and the rest are of the same weight. In how many minimum weighings will you find the heavier ball? And when we say weighing, think of a scale where you can put objects on one side and the other, and you can see which side is heavier. And you want to minimize that. You want to split the balls up in such a way that you're going to do as few measurements as you can. You will need to perform 2 weighings. So you can get it down to just 2 weighings. And I always think if there's 9 balls, I'm going to divide them into 3 groups of 3. Place 3 balls on each side. So you can just randomly pick 6 of the balls and 3 on one side, 3 on the other. And if they balance out, both sides are equal, then you know the heavy weight isn't in any of those. So out of the remaining 3 balls from step 1, take 2 balls and place 1 ball on each side. A little tricky there because I always want to put all 3. I want to put 2 on one side and 1 on the other, but no, just randomly pick 2 of those, put 1 on each side. If they balance out, then the left out ball, the one you didn't measure, will be the heavier one. Otherwise, you'll see it in the balance. You'll see which one's heavier because you'll take one of the balls down. Now we go to scenario B, where they did not balance out. So now we know which side has a heavier ball in it. And it's just very similar to what we did before. If the balls in step 1 do not balance out, then take those 3 balls that had the heavier side on them and reproduce step 2 to find out the heavier ball. Difference between univariate, bivariate, and multivariate analysis. And hopefully, if you know a little Latin, it'll kick in there that you have uni and you have bi and you have multi, because the answer is in the words themselves. So the first one, this type of data contains only 1 variable. So that's the univariate. The purpose of the univariate analysis is to describe the data and find patterns that exist within it. So when you only see one variable coming in this case we're using height of students, you're limited as far as what you can do with that data. So you can come up and draw different patterns and conclusions from those patterns using the means, the median, the mode, dispersion, range, minimum, maximum. So we're describing the data. So all those words would describe the data, and that's about all you can do with data like that. There's no correlation, there's nothing to go beyond that as far as guessing or predicting anything. So we move into bivariate. Uni means 1, bi means 2. Bivariate, this type of data involves 2 different variables. The analysis of this type of data deals with causes and relationships, and the analysis is done to find out the relationship among the 2 variables. And this is always a favorite one because everybody loves ice cream in the summer when it's hot, and very few people go for ice cream in the winter when it's really cold, so it's easy to see the correlation in the data. The temperature and ice cream sells in summer season. prediction. And you can see here where the temperature goes from 20 to 35, and as the temperature goes up, so does the sales of ice cream. It goes from 2,000, I'm not sure 2,000 of what, so I'm guessing it's a very large chain, because if they're selling 2,000 ice cream cones, and they have a lot of business, good for them. You know, a little vendor on the corner selling 2,000 ice cream cones a day and 3,100 the next day. Here, the relationship is visible from the table that temperature and sales are directly proportional to each other. So the hotter the temperature, we can predict an increase in sales. So the word prediction should come up. So we have description and prediction. When the data involves 3 or more variables, it is categorized under multivariate. It is similar to bivariate, but contains more than one dependent variable. In this example, another really common one, the data for house price prediction, the patterns can be studied by drawing conclusions using mean, median, and mode, dispersion, or range minimum, maximum, etc. And so you can start describing the data, that's what all that was, and then using that description to guess what the price is going to be. So this is very good if you're in the market and you have already looked at the area and you already know that a 2-bedroom, 0-floor, 900 square foot house usually runs about 40,000. You can guess what the next one that looks similar to it is. And I'll just throw in another word in there I don't see very often unless you're really a hardcore data science. We talked about describing the data, descriptive. We talked about predictive, and there's also postscriptive. Postscriptive means we're going to change the variables to try to guess what the outcome is if we change what's going on. So that would be the next step. But that usually doesn't show up unless you're dealing with some really hardcore data science groups. What are the feature selection methods to select the right variables? There are 2 main methods for feature selection. There's filter methods and wrapper methods. And when you're filtering before we discuss the 2 methods real quick, the best analogy for selecting features is bad data in, bad answer out. So when we're limiting or selecting our features, it's all about cleaning up the data coming in so it's cleaner and is more representative of what we're trying to predict. Filter method. Filter methods as they come in, we have linear discrimination analysis, ANOVA, chi-squared. Chi-squared is probably the most common one. And these are all part of pre-processing. We're taking out all the outliers, all the things that have a difference that is very different from the data we're looking at, the odd ones. And sometimes you take the odd ones out and then you analyze them separately to see why they're odd. But remember your filter methods, you want to pull all that weird stuff out. Wrapper methods, on the other hand, are forward selection, backward selection, recursive feature elimination. And one of the most important things to remember about wrapper methods is they're very labor intensive. You have to have some pretty high-end computers if you're doing a lot of data analysis with the wrapper method. And just quickly, forward selection means you have all your different features. They're off to the side, and we test just one feature at a time, and we keep adding them in until we get a good fit. Backward is we have all the features, and we run a test on that to see how well it does, and then we start removing features to see what works. And recursive, which is the most processing-hungry algorithm out there, goes through and just recursively looks through all the different features and how they pair together. But again, we have filter method and wrapper method, and it's important to understand that we're sorting the data out and finding out which features are going to represent the data the best and which ones are not going to really add any value to our models. Let's jump to number 8. In your choice of language, write a program that prints the numbers from 1 to 50, but for multiples of 3, print fizz instead of the number, and for the multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fizz buzz. And this really is testing your knowledge in iterating over data. Very important. My sister, who runs at the university the data science team, is in charge of their department. The first question she asks in her interview of anybody who comes in is, how do they iterate through data? So if this question comes up a lot and it's very important you have an understanding, and there's actually a slight error on this code, which I'll point out in just a second. The concept is we have fizz buzz in range, and you have range 51, which in this case goes from 0 to 51. And I'm going to challenge you to see if you can catch the error, and I'll tell you at the end of the code where the error is. What that means is that we're going to go through all the numbers 0, 1, 2, 3, 4, and we're going to process through this loop. If the remainder of fizz buzz divided by 3 equals 0, and fizz buzz divided by 5 also equals 0, then print fizz buzz. Continue. And else if fizz buzz divided by 3 equals 0, then print fizz, continue. Else if fizz buzz divided by 5 equals 0, print buzz, continue, and print fizz buzz. You print the answer. In this case, fizz buzz is either going to be the number we generated, which is 0, or it'll be the fizz buzz, fizz, or buzz. Whew, that's a mouthful. Now, if you didn't catch the error in the code, which is always a fun game, find the error. It has to do with the range. And it's important to remember the range here says range to 51. That's 0 to 51, which is correct. We want to go to 51 because it stops. It gets to 50 and it stops. So that's 0 to 50. But if you remember, the question asks from 1 to 50. So the range should be 1, 51, not just 51, which does 0 to 51. In this particular script, in Python, you could leave out the continue, but the continue in this script skips the next else if, so it doesn't keep processing it going down. And in programming, a lot of scripts you don't need the continue answer, so it would depend on what script you chose. And there's probably some other ways to do this. It's a lot of fun. And you can see here from the output, we end up with fizz buzz for 0, which shouldn't be there. 1, 2 fizz, 4 buzz fizz, 7, 8 fizz buzz, 11 fizz, and so on. Sounds like a drinking game from my college days. So long ago, many decades ago. You are given a data set consisting of variables having more than 30% missing values. How will you deal with them? Oh, the joy of messy data coming in. Ways to handle missing data values. Data set is huge. We can just simply remove the rows with missing data values. It is the quickest way, i.e. we use the rest of the data to predict the values. You just go in there and say any row of our data that has a NA in it, get rid of it. That doesn't work with smaller data. So with smaller data, you start running into problems because you lose a lot of data. And so we can substitute missing values with the mean or average of the rest of the data using Pandas data frame in Python. There's different ways to do this, obviously, in different languages. And even in Python, there's different ways to do this. But in Python, it's real easy. You can do the df.mean, so you get the mean value. So if you set mean equal to that, then you can do a df.fillNA with the mean value. Very easy to do in a Python Pandas script. And if you're using Python, you should really know Pandas and Numpy, NumPython and Pandas data frames. For the given points, how will you calculate the Euclidean distance in Python? So back to our basic algebra from high school. Euclidean distance is the line on the triangle. And so if we're given the points plot 1 equals 1, 3, plot 2 equals 2, 5, we know that from this we can take the difference of each one of those points, square them, and then take the square root of everything. So the Euclidean distance equals the square root of plot 1, 0 minus plot 2 of 0 squared plus plot 1 of 1 minus plot 2 of 1 squared. Mouthful there. And you can remember if you have multiple dimensions that go past 2 dimensions, you could have plot 3 can simply be the distance from plot 1. You only need to do one side of that. Or plot 2, you can do either way and square that and take the square root of that. Another mind bender. How to calculate something, how to figure out the solution to something. What is the angle between the hour and minute hands of a clock when the time is half past 6? So you want to kind of imagine that clock where the large hand is pointed down to the 30 and the other half is going to be right between the 6 and the 7 because it's half past 6. There's actually a couple ways to solve this, but let's take a look and see how they did it. Note, a clock is a complete circle having 360 degrees. In 1 hour, the hour hand covers 360 over 12, so it equals 30 degrees for each hour. In 1 minute, the minute hand covers 360 degrees over 60 minutes, or 6 degrees per minute. The minute hand has traveled for 30 minutes, so it has covered 30 times 6, which equals 180 degrees. So we know that's 180 degrees from the 12. The hour hand has traveled for 6.5 hours, 6.5, 6.5, so it's covered 6.5 times 30, which equals 195 degrees. The difference between the two will give the angle between the two hands. Thus, the required angle equals 195 minus 180 equals 15 degrees. And this is nice the way they solved it because you can now punch in any kind of time within reason. The hard part is on the hours, is you have to be able to convert the hours into decimals. Explain dimensionality reduction and list its benefits. Dimension reduction refers to the process of converting a set of data having vast dimensions into data with lesser dimensions, fills, to convey similar information concisely. It helps in data compressing and reducing the storage space. It reduces computation time as less dimensions lead to less computing. It removes redundant features. For example, there's no point in storing a value in 2 different units, meters and inches. And I certainly run into a lot with this with text analysis. I've been known to run a text analysis over a series of documents, ends up with over 1.4 million different features. That's a lot of different words being used. And if you do what they call connect them, you connect 2 words together, now you're up to 4.8 million different features, and you start having to figure ways to bring that down. What can we get rid of? That kind of thing. So you can see where that can get really high in on processing, and learning how to reduce the list dimensions is very important. How will you calculate eigenvalues and eigenvectors of a 3x3 matrix? And what they're really looking for here is when you write it out, for the eigen is that you know that you're going to use the lambda. That's the most common one. Obviously you can use any symbol you want, but lambda is usually what they use. And that you do it down the middle diagonal. And so when you take that matrix and you take the characteristic equation, you end up with the determinant, and that's the -2 minus lambda, -4, 2, -2, 1 minus lambda, 2, 4, 2, 5 minus lambda. And that's what they're looking for, and you know that's equal to 0. So when you're doing a matrix in the eigen setup with the eigenvectors, that's all going to come out equal to 0. And then you can go ahead and write the whole equation out. So we can expand the determinant, as you can see right here, the -2 minus lambda times, it's a mouthful. I'll leave it up here for a second so you can look at it. When you break it down into the algebraic functions, you end up with minus lambda cubed plus 4 lambda squared plus 27 lambda minus 90 equals 0. So now we have a nice algebraic equation built from the eigenvectors. And always remember, you can hit the pause button, and you can also send a note. Send a note to Simplilearn if you have more questions on vectors or on this. Definitely have that resource available to you, or post down in below on the YouTube video comments. And so when we calculate the eigenvalues and eigenvectors of a 3x3 matrix, as we continue on down the math of this, and to be honest, I really don't like working with matrices like this. It's important to understand the math behind it, and it's important to know the code just enough so that you're not lost when someone's explaining it or it comes up when I'm working on different data science models. Of course, if you're dealing with the high-end math side of it, then you better know this. First is by hit and trial. So you try in different variables to solve for 0, and you can come in here and you'll find that if we put in the 3 in there, we end up with a 0 at the end, and substitute the 3. Hence, we end up with lambda minus 3 as one of the factors. And you can do the math going out on that, where we have lambda cubed minus 4 lambda squared minus 27 lambda plus 90 equals lambda minus 3 times lambda squared minus lambda minus 30. So eigenvalues based on that one are 3, minus 5, and 6. And then from there we can calculate the eigenvector for lambda equals 3. And you can see here where the matrix as we write it out is the minus 5, minus 4, 2, minus 2, minus 2, minus 2, 4, 2, 2. That was from the beginning. Put in the x, y, and z equals 0, 0, 0. And so when we put in those numbers and we calculate them out, we have for x equals 1, we have the minus 5 minus 4y plus 2z equals 0, minus 2 minus 2y plus 2z equals 0. And subtracting the two equations we just had, we get 3 plus 2y equals 0, y equals minus 3 over 2, and z equals minus 1 over 2. That's going back to the first equation. And similarly, we can calculate the eigenvectors for minus 5 and 6. How should you maintain your deployed model? Ooh, distribution time. My favorite. I spent 10 years in software distribution. So first thing, and this is true not just of your data science model, but of any computer code going out there. This is basic setup can work, although usually there's a little added steps in there. First, we're going to monitor it. So we have a constant monitoring of all the model is needed to determine the performance accuracy of the models. So yeah, we want to just keep an eye on it. We want to make sure they're accurate. We want to make sure that whatever they're supposed to predict, or I threw in that bonus word, postscript, where you've changed something and you want to figure out how your changes are going to affect things, we need to monitor it and make sure it's doing what it's supposed to do. Evaluation metrics of the current model is calculated to determine if new algorithm is needed. And then we compare it. The new models are compared against each other to determine which model performs the best. And then we do a rebuild. The best performing model is rebuilt on the current state of data. And this is interesting. I found this out just recently. If you're in weather prediction, the really big weather areas have about 7 or 8 different models depending on what's going on. And so you actually have almost a little forest going on there where they're like, which model is going to fit best, and this is what we're going to use to predict the weather with. So not only do you don't necessarily get rid of the models, but you figure out which models fit data of what's going on, or the current state of data. What are recommender systems? Most commonly used nowadays in marketing, so very big industry, understanding recommender systems, predicts the rating or preference a user would give to a product. And they're split into 2 different areas. One is collaborative filtering, and a good example of that is the Last.fm recommends tracks that are often played by other users with similar interests. So people who, if you're on Amazon, people who bought this also bought that. This got me a few times. And then there's content-based filtering. And we're looking at content instead of looking at who else is listening to the music. They use the example Pandora, which uses the properties of a song to recommend music with similar properties. So you have collaborative filtering and content-based filtering. How to find Rmse and MSE in linear regression model. Hopefully you remember what the two acronyms mean, because that is like half the answer. We have the root mean square error and the mean square error in linear regression model. So we're looking for error. The Rmse and the MSE are the two of the most common measures of accuracy for a linear regression model. And you can see here we have the root mean square error, Rmse equals, and this is the square root of the sum of the predicted minus the actual squared over the total number. So we're just looking for the average, mean. So we're looking for the average over the n. And the reason you need to know about the difference between Rmse versus MSE is when you're doing a lot of these models and you're building your own model, why do you need to take the square root of it? It doesn't change the value as far as the way you're using it, because you're looking as to see whether the error is greater or less than. So why add that extra computation in? So a lot of models use the MSE, which indicates the mean square error or the average error. And it's the same formula minus the square root at the end or across the whole thing. Another riddle to solve. If it rains on Saturday with a probability of 0.6 and it rains on Sunday with a probability 0.2, what is the probability that it rains this weekend? And the trick in probabilities on this case is we need to know what is the probability of it not raining. What's the chance of it not raining on Saturday? And if it doesn't rain on Saturday, we want to take that and combine that with the chance of it not raining on Sunday. The total probability, which in this case we're just going to use 1, minus the probability that it will not rain on Saturday, so that's 1 minus 0.6. We're going to take that as a union, which we simply just multiply them together, of the probability that it will not rain on Sunday. And it's important to recognize the union here, or and you can see by the formula down here, we end up with 0.68 or 68% chance that it will rain on the weekend. And there are a couple other ways to solve this, but this is probably the most traditional way of doing that. How can you select k for k-means? So first you better understand that what k-means is, and that k is a number of different groupings. And most commonly we use is the elbow method to select k for k-means. The idea of the elbow method is to run k-means clustering on the data set where k is a number of clusters. Within the sum of squares, WSS is defined as the sum of the squared distance between each member of the cluster and its centroid. And you should know all the terms for your k-means on there. And with the elbow point, and again, here's our iteration in our code. We talked about that earlier. You iterate starting with, usually you don't start right at 1, but you might start with 2, 3, or 4. And you just see where it comes out, and you can see the nice elbow there, which is easy to see graphically, where the number of k clusters and the WSS value drops, and then it just kind of flattens out, and there's no reason to take the k-means any further. What is the significance of p-value? Oh, good one. Especially if you're dealing with R, because that's the first thing that pops up. P-value, typically less than or equal to 0.05, indicates a strong evidence against the null hypothesis. And you should know what a difference, why we use null hypothesis instead of the hypothesis. So you reject the null hypothesis. Very important, that term null hypothesis in any scientific setup, and also in data science. It doesn't mean that it's true. It means that there's a high correlation that it's true. So if your null hypothesis means it's not true, your hypothesis has a high correlation that it's probably true. And if the p-value is typically greater than 0.05, it indicates a weak evidence against the null hypothesis. So you fail to reject the whole null hypothesis, and if you reject that, then your actual hypothesis is probably not true. The correlation of your data with what you think it's saying is probably incorrect. And if you're right at the cutoff of 0.05, it's considered to be marginal. Could go either way. And again, you can use that p-value on different features to decide whether you're going to include your features as far as something worth exploring in your data science model. How can outlier values be treated? Ooh, good one. You can drop outliers only if it is a garbage value. So sometimes you end up with like one outlier that just is probably someone's measurements way off. Height of an adult equals ABC feet. This cannot be true as height cannot be a string value. In this case, outliers can be removed. If the outliers have extreme values, they can be removed. For example, if all the data points are clustered between 0 to 10, but one point lies at 100, then we can remove this point. And again, sometimes you just look for the outliers so you can see what's going on if there's something unusual there. So maybe the equipment's not calibrated correctly. If you cannot drop outliers, you can try the following. Try a different model. Data detected as outliers by linear model can be fit by nonlinear model. So be sure you are choosing the right model. So if it has like more of a curved look to it instead of a straight line, you might need to use something other than just a straight line linear model. Try normalizing the data. This way the extreme data points are pulled to a similar range. If you can use algorithms which are less affected by outliers, example random forest. So there's another solution, is you can come up with the random forest, which a lot of times completely bypasses your outliers. How can you say that a time series data is stationary? Oh, that's an interesting term. Stationary, meaning it's not moving, but it's a time series. We can say that a time series is stationary when the variance and mean of the series is constant with time. And the graphic example is very easy to see. We have our the variance is constant with time, so we have our first variable y and x being the time factor and y being the variable. As you can see, goes through the same values all the time. It's not changing in the long period of time. So that's stationary. And then you can see in the second example, the waves get bigger and bigger, so that's non-stationary. Here the variance is changing with time. Again, we have y, which stays constant, so that if you look at the bigger picture, it's the same wave over and over again. And then of course we have where the wave is growing in size going up. It can also go down, so it'd also be non-stationary. How can you calculate accuracy using confusion matrix? Oh, great one. Confusion matrices are so useful when you're taking that first look at data, and also when you're showing the shareholders and you want to ask them for money. How can you calculate accuracy using confusion matrix? So you have your total data that we're looking at is 650, and you have your predicted values and your actual values, and you have your predicted P and your actual P. And so when you look at this, you'll note that if the predicted P and the actual P are 262, but our predicted P also had 15 that weren't correct. So you can see there's a false positive there of 15. And the same thing with the N. You can see where N predicts N, and it has a false negative of 26 out of the total number of N values in there. And so we can do an accuracy on there. The true positive plus the true negative is our total observations. So you have a total of 0.93 accuracy, or 93%. And just a quick note on this, this is so important, because it's one thing if someone is being diagnosed with, say, cancer. This is life-death, or is my nuclear reactor going to blow up? Suddenly, if the P is the probability of it blowing up, and this, let's say you have 15, that's a lot less than, say, the 26 chances of it blowing up. So the actual domain of your data is very important. So if you're non-positive, you don't really care about the predicted value having non-positive as positive, because they're going to go do a biopsy on the cancer or whatever anyway. But you're very interested if you have a positive, an actual positive value, which is looked at as negative, a false negative. That's really important in that domain, depending on what domain you're in. Write the equation and calculate precision and recall rate. And so continuing with our confusion matrix, I was just talking about the different domains. We have the precision equals 262 over 277. So your precision is the true positive over the true positive plus false positive. And the recall rate is your true positive over the total positive plus false negative. And you can see here we have that 262 over 277 equals a 94%. And the recall over here is the 262 over 280, which equals 9.9 or 90%. And oh good, we're going to take a pause for another brain teaser. If a drawer contains 12 red socks, 16 blue socks, and 20 white socks, how many must pull out to be sure of having a matching pair? The last time I went through these kind of brain teaser things was like 20 years ago, and I had 6 people sitting across the table waiting for my answer. That's kind of mind-numbing when you're in an interview like that. Hopefully you're not stuck in an interview like that. But on this, you need to ask yourself, how many different colors of socks are there? So they've thrown a lot of extra data in here that you don't need to solve the answer. The answer is 4. An example, your first pick is white, your second pick is red, third pick is blue, so no pairs yet. And that means when you get to the fourth pick, there's a 100% chance you're going to have a match. So the most is going to be 4 that you ever have to pull out of your drawer. If it was 4 colors, the answer would be 5, and so on. It doesn't matter how many white socks you have, or how many red socks or blue socks, different pairs you have. It's the different colors, the number of different colors. People who bought this also bought recommendations seen on Amazon as a result of which algorithm? Ooh, we covered this earlier. Recommendation engine is done with collaborative filtering. Collaborative filtering exploits the behavior of other users and their purchase history in terms of ratings, selection, etc. It makes predictions on what you might interest a person based on the preference of many other users. In this algorithm, features of the items are not known. And we have a nice example here where they took a snapshot of a sales page. It says, for example, suppose X number of people buy a new phone and then also buy tempered glass with it. Next time when a person buys a phone, he'll be recommended to buy tempered glass along with it. And if you remember the vocabulary words we covered earlier, this is the recommendation. This is collaborative. The other word was content-based. So looking at things with similar content versus collaborative, which is similar people. And remember, you're not going to know every vocabulary word, but it also doesn't hurt to get your 3x5 cards out and make yourself a vocabulary stack of cards. Buy an app on your phone for it. SQL Query. I remember back in the 90s, it was so important to know SQL Query and only a few people got it. Nowadays, it's just part of your kit. You have to know some basic SQL. So write a basic SQL query to list all orders with customer information. And you can kind of make up your own name for the database. And you can pause it here if you want to write that down on a paper. And let's go ahead and look at this. We have to list all orders with customer information. And so usually you have an order table and a customer table. And you have an order ID, a customer ID, order number, total amount. And then from your customer table you have ID, first name, last name, city, county. And so if we're going to write in SQL with this, we're going to select, keyword there for SQL, selecting, order number, total amount, first name, last name, city, country. So that's the columns we're going to look at. We're going to do that from our order, where we're going to join it with our customer, and we're going to join it on the order customer ID equals the customer ID. So very basic SQL query that's going to return a table of data for us. You are given a data set on cancer detection. You've built a classification model and achieved an accuracy of 96%. Woo, 96%! Why shouldn't you be happy with your model performance? What can you do about it? That's an interesting one because this comes up. That's one of the standard data sets on there is for cancer detection. Cancer detection results in imbalanced data. In an imbalanced data set, accuracy should not be based as a measure of performance because it is important to focus on the remaining 4%, which are the people who were wrongly diagnosed. We talked a little bit about this earlier. You have to know your domain. This is the medical cancer domain versus weather domain. Weather channel, they can get by with 50% wrong. In cancer, you don't want 4% of the people being wrongly diagnosed. Wrong diagnosis is of a major concern because there can be people who have cancer but were not predicted so. In an imbalanced data set, accuracy should not be used as a measurement of performance. Which of the following machine learning algorithm can be used for inputting missing values of both categorical and continuous variables? So we have a couple choices here. We have k-means clustering, we have linear regression, we have the KNN, nearest neighbor, and decision tree. And which of the following machine learning algorithms can be used for inputting missing values of both categorical and continuous variables? Now, certainly you can use some pre-processing to do some of that, but you should have gone with the K nearest neighbor because it can compute the nearest neighbor, and if it doesn't have the value, it just computes the nearest neighbor based on all the other features. Where when you're dealing with k-means clustering or linear regression, you need to do that in your pre-processing, otherwise it'll crash. Decision trees also, although there's some variance on that too. Can you solve? Another riddle, always fun ones. Given a box of matches and two ropes, not necessarily identical, measure a period of 45 minutes. And in this particular setup, the ropes are not uniform in nature, and the rope takes exactly 60 minutes to completely burn out. So each rope takes up to 60 minutes to burn out. And there's actually a couple different solutions to this. But let me go ahead. And one of the things is they're not uniform in nature. So even though they take 60 minutes... Anyways, let's go ahead and see what they did to solve it. And then we can also look at different options. We have two ropes, A and B. Light A from both ends and B from one end. Okay. When A is finished burning, we know that 30 minutes have elapsed and B has 30 minutes remaining. Now light the other end of B also so that the remaining part of B will burn, taking 15 minutes to burn. This we have gotten 30 plus 15 equals 45 minutes. Excellent solution. Mine, which I like, was to take one rope, fold it in two, so we know it's a half hour. Take the other rope, fold it in 4 places, so we know that that one's 15 minutes, and then you can just connect the two and burn it straight across. I think they're trying to cover that by saying they're not regular. The ropes have some irregularities. Maybe that's what they meant by that, is you couldn't do something like that. But that's my solution. Below are the 8 actual values of target variable in the train file. So we have a training file, not to be confused with the train on the tracks. We have 0, 0, 0, 1, 1, 1, 1, 1. What is the entropy of the target variable? We mentioned earlier that you should know your entropy and how to calculate the entropy. What is the entropy of the target variable? So we have a couple options here. We have minus 5 over 8 logarithm of 5 over 8 plus 3 over 8 logarithm of 3 over 8. Okay, let's just see where they got those numbers from. We have 1, which is going to be 5 ones and 3 zeros, and then we have a total of 8. Okay, and then we have the option of 5, which is number of ones, 5 8 logarithm of 5 eighths plus 3 eighths logarithm of 3 eighths. And we also have 3 eighths logarithm of 5 eighths plus 5 eighths logarithm of 3 eighths. And then we kind of reverse those numbers around. And let's see what you're going to get here. Which one did you think it was? You should have checked the first one. So what is the entropy of the target variable? The key there is the target variable. So we're looking at the target in this case is going to be 1. Usually that's what you're looking for. And so the entropy of that one, we want to subtract out the entropy of the non-target variable. Whoops, I had that backwards. We're looking at 0, so we want to subtract out the 5 eighths from there. So 5 eighths logarithm 5 eighths, or negative 5 eighths logarithm 5 eighths plus 3 eighths logarithm 3 eighths. And they have the hint on the bottom, entropy equals I of P of N. So we have a negative P plus P and N times the logarithm base 2 of P over P plus N minus the N over P plus N times the logarithm 2 of N over P plus N. We want to predict the probability of death from heart disease based on 3 risk factors: age, gender, and blood cholesterol level. What is the most appropriate algorithm for this case? So we have 3 features, and we want to know the predictability of death. Okay, a little morbid there. Choose the right algorithm. Do we want to use logistic regression for this, linear regression, k-means clustering, or the Aporia algorithm? And if you selected logistic regression, then you probably got the right answer. Linear regression, remember, deals with you take your line and draw a line through the data. And of course, you don't necessarily have to use a straight line. There's other means for that. But you're dealing with a lot of numbers. And k-means means we're just going to cluster objects together. With the logistic regression, though, you can mix those things together in buckets. So really, the logistic regression is what you want to use in that model, would be the most apt fit. After studying the behavior of a population, you have identified 4 specific individual types who are valuable to your study. You would like to find all users who are most similar to each individual type. Which algorithm is most appropriate for this study? Certainly, identifying census in just about a lot of different markets is common, so maybe they have a census or whatever it means. But let's take a look at some of the different algorithms we might use on this. We have k-means clustering, linear regression, association rules, and decision trees. And I'll give you a hint. We're looking for grouping people together by similarities, and by 4 different similarities, so very specific. They gave you one of the values, specifically the k value. So k-means clustering would be great for this particular problem. You have run the association rules algorithm on your data set, and the 2 rules, banana apple is associated with grape, and apple orange is associated with grape, have been found to be relevant. What else must be true? So this would challenge you to understand association rules. You could picture in this particular one, you're going shopping, and you almost always see somebody who has bananas, they usually have grapes in their bag also. And somebody who has apples usually has grapes in their bags. And then apples and oranges is also associated with grapes. And let's go ahead and take a look at that. And we have a couple different options here. First one is banana, apple, and grape, orange must be a frequent item set. Not so much. Banana, apples, oranges must be relevant rule. Grape is common with banana, apple, must be a relevant rule. And how about grape, apple must be a frequent item set? Let's go back and take a look at that. And we notice that we have bananas, apples to grapes. We have apple, orange to grape. Boy, there's a lot of grapes and a lot of apples in there. And so if you said the last one, grape and apple must be a frequent item set, then you got it correct. Your organization has a website where visitors randomly receive one of 2 coupons. It is also possible that visitors to the website will not receive a coupon. You have been asked to determine if offering a coupon to visitors to your website has any impact on their purchase decision. Which analysis method should you use? And so let's go ahead and start by giving you another hint and give you some limiting your selection. We have a one-way ANOVA, k-means clustering, association rules, and student t-test. So obviously you should know what each one of these means, but let's take a look at the question again. So you want to know which method should you use to see if the coupon's valid for their purchase. Well, we're not clustering and we're not associating things together. We want to know the end result. Student t-test also drawing that little t in boxes and switching them around. There's really only one answer that works in here, and that's a one-way ANOVA. So that draws us to an end. I want to thank you for joining us today. For more information, visit www.simplilearn.com. Get certified, get ahead. Feel free to visit our website and ask any additional questions you have. You can also post questions down below in the YouTube video, and we'll try to get one of our experts will try to reach out to you and answer those questions. Again, thank you for joining us and happy learning. And since these are interview questions, good luck on your next interview. Or if you're the interviewer looking for questions to ask people, good luck on your next interview.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.